want to thank you, Guillermo, and also Guido for hosting us here at Central Queensland University, and also for organizing the show, the workshop. So we have prepared a very non-standard talk in the sense that we have not focused on a particular result. The idea was to present our research, our recent projects, and choosing two case studies, real case studies, in order to show how we have applied logic. So, okay, it's a different kind of talk because we wanted to basically present ourselves and see if there is some possible collaborations. And so perhaps we better present ourselves. I am a full professor at the University of Barcelona, and in Barcelona we have some of you know that there is a big group that is devoted to philosophical and mathematical logic, that the studies range from set theory, model theory, to logic for artificial intelligence. So I started in this group doing hard model theory for algebraic structures. And then in 2000, I moved to the same institute where Vicent is working, which is the Institute for Artificial Intelligence. And then I moved my research to physiology, but keeping the idea of studying more from a theoretical point of view, which is mainly physiology for first-order logic. We collaborated with Pilar in some papers, but at the same time, we collaborate in practical, implemented projects. And then, first of all, was the classic old-fashioned artificial intelligence, which symbolic logic was very present. And we explore a variety of formalisms, logical formalism, not only fuzzy logic, but also model logic or deontic or description logics. And now we have encountered that in our institute, things are changing because deep learning is very important, and we have tried to experiment. What does it mean? Is to explore mainly something which is related to explainability in artificial intelligence, and other things that have changed is mainly also in the field of philosophy, is that ethics is a must. So now I am coordinating the AI ethics committee of our university, and there are a lot of issues, especially since the new AI Act, the European normative is developing. And so this is also one of our research centers. So, Vicent, if you want to introduce yourself.
Okay, so as Pilar already said, we could say that we are trying to explore which role has the logic-based methods, the symbolic approach, into the current era. So because I didn't introduce myself, I'm Vicent Costa, and as Guillermo said, I'm a technical scientist at the Artificial Intelligence Research Institute, which is a center located inside the campus of the Autonomous University of Barcelona. Again, if as you know, they are separated institutions, and my research topics are related to those of Pilar, so she already said. In that sense, we wanted to present today two cases that we are going to enter into the details later. But our idea was also to, in some sense, put the general context of all of our research. In this point, we like to remind that our research follows the guidelines applied by the Spanish National Research Council, which are also some outlines shared by the community of artificial intelligence globally. So usually when we present our research in AI conferences, we need to specify that we want to work with small data set, we really want to design hybrid systems, and we also, in some sense, use logic for representing different kind of notions. Today, the audience is different, so we can say that in some sense we are like defending or showing how logic can have a role into the context of AI. And as already Pilar said, we are also interested in the ethical and social implications of the design and the use of AI systems. So you will see that today there are two study cases. One of them, in principle, does not present real ethical implications a priori, and the other one for sure has a lot of social impact. So you will see how the second one is more related to that topic. So, as Pilar already said, we are interested in explainability. You know that explainable AI is like the hot topic today in artificial intelligence. We are going to understand it in a narrow sense, in the sense that for us, XAI or explainable AI is committed to design systems that provide explanations of the outcomes, the decisions, the actions, the results, things like that. So the idea is that, perhaps most of you already know, but we wanted to recall it. Because in the 70s, the AI systems were very interpretable, so explainability was something that, even if it was not the hot topic, AI systems in that generations were explainable, but nowadays systems show high accuracies, good performances, but perhaps they are not so interpretable. So in some sense, XAI tries to fix this problem, you know, that our AI systems, our current AI systems are quite good in terms of predictions, but they lack explainability. So, sorry. The first case study we want to present you is hyperpainting style categorization. In that sense, we were motivated. The main motivation was that we wanted to explore how logic could be integrated into an AI system in order to present explanations, and also in order to perform a typical task in artificial intelligence, which is, in that case, classifying paintings into art styles. In this sense, we believe, as I already said, that these domain applications did not present ethical challenges in the beginning. So it was a good idea to start in this point. So as you know, this is there are a lot of works in AI related to the categorization of art styles. For instance, on the slide, you can see works from dated to 2006. But what was our starting point? We saw that some authors explored the idea of using qualitative concepts, and in particular color filters, in order to categorize painting into art styles. So that was our starting point. And here we had also like a cognitive hypothesis, following the idea that perhaps color could be enough for classifying painting into these three art styles, into the Baroque, the Impressionism, and the Post-Impressionism. So we posed a couple of objectives. First of all, we wanted to design an explainable systems using only color traits, you know, following that cognitive hypothesis. We also wanted, as Pilar already said, our system to be logic-based, in the sense that we wanted to explore in 2018 what could be the role of logic in that design. We also, of course, wanted to design an AI system able to generate explanations. And what was also quite important was that we wanted our system to be competitive with other proposals in the literature, because, you know, explainability is good, but if our system is not precise, we are not going to propose anything solid in the context of AI. So these slides were just to say that if you are curious, there are a couple of publications related to this project. And then let's make a fast preliminary basics, you know. We speak about color space. Color space we can understand as a way of representing or specifying colors. Usually they have three coordinates, and the most well-known color space is the RGB, which states wherein a color is determined by the three coordinates, you know, corresponding to the primary colors. we use another color space, but this is not so important. What we wanted to say here is that that was our starting point of view, color, but we needed in the end that our explanations needed to be understandable in a general way. So we didn't want to work just with quantitative data as 3 coordinates. So we use the qualitative color descriptor model. What is the idea here? That given a pixel in a digital image, that model extracts the 3 coordinates in the color space, but then, and this is what is important, it assigns a color label to this pixel. That color label actually, and that name of the color was obtained empirically from people. So, in principle, the labeling of that model will be cognitively understandable for us. For instance, yes, that you have one pixel here, and that could be labeled as light yellow, for instance. No? So, then what we do was to define digital images using set of logical facts, as you can see on the slide. For instance, for that painting from the left here, you can see, I don't know if you can see the last logical fact, but the idea is that the 2% of the pixels in the image correspond to the label white. So that was our way of using logic in principle only for representing the images. Then, since what we wanted was to categorize these 3 art styles, we went to the art experts in order to know which were the color filters more characteristic of each art style. So, for instance, in the Baroque, you can see that the presence of dark colors was quite prominent, also the indoor scenes, and that thing that is named chiaroscuro, which is the contrast between dark and pale light colors. Or for instance, in the Impressionism, we have other color filters, Since we have outdoor scenes, the blues, the greens, and the variety of colors and hues were more prominent. So here, the first thing that we wanted was, okay, we could just go and formalize that knowledge and design our system. So we wanted to do something more. First of all, we wanted to see the color trace proposed were meaningful for people, not only for the system. So we conducted a survey, which was not a serious cognitive experiment, but it was some approximation to the problem, where we asked people to classify paintings taking into account only information about the color trace of its art style. So for instance, we explained them that the post-impressionism has some color features, and we asked participants to classify paintings using only that information. And the results show that in general, people were able to do that. So in some sense, we get a validation of that proposals of color trends. Regarding logics, because today is a very logical audience, we work in the whole fragment of T-norm-based logics. I guess that all of you already know about that. A T-norm is a binary function which is usually used to interpret the strong conjunction. Okay, so it's just that. And then we speak about T-norm-based logic because from the T-norm, we also define the interpretation of the conditional just as the residuum of the T-norm. The whole fragment, I believe that is very well known as well. Classical whole formulas are disjunctions of literals with at most one positive literal, and the typical way of representing them is with a conditional. From long time ago, a lot of people has explored the root properties in computer science and also in logic programming. So what we saw was that we needed something more. We needed a more expressive language. So we go from the classical syntax to an evaluated syntax of this. These were what we named evaluated so because it doesn't work, color formulas, and the idea that was that we have rational constants in a unit interval, and we have atomic formulas, and we have this kind of pairs that represent conditionals. Yes, that this is quite typical to do in that way. So we evaluated each one of the atomic formulas. And what we did was to, as you can guess, we are going to use all this theoretical framework to represent the knowledge about the arc styles, but also for reasoning and for classifying benefits. So we define the 12 color traits as propositional variables, and actually the interpretations of each color test were given by the information extracted with the qualitative color descriptor model. And then we represent the knowledge about each one of these styles using the evaluated formulas. You can see, for instance, in the Baroque, if you remember the color tests that we highlighted are also present here. Okay, but as I was saying, logic was not only used for representing, but also for reasoning, and of course, for performing the task, for classifying paintings. So we explored the three most prominent inner-based logics, which are Ukasevic, Gödel, and product logic. Before continuing with the design of the model, let us say that at the beginning, we mentioned that we would like to work all the time with a small databases, not only us, but this is like some challenges for our discipline and for this in particular. So let us remind that a lot of data sets related to art are on the internet and in the literature, and they are really, really large. However, we only use these two data sets, which are quite small because they have 337 pages. So in that sense, we were aligned with the big challenge that we mentioned before. So what was the idea? I'm not going to give details because I think that it's not the moment, but we had an input, which is a digital image, and from the very first beginning, we already used logical facts to represent the input, and then we obtain values for each one of the characteristic color traits that we define. You know, we can see, for instance, the darkness level can be understood just as the sum of the frequencies of the colors that are dark. And then we use logic for obtaining a membership degree of the painting study into each one of the art styles. So here, yes, the idea was to evaluate the antecedent of the evaluated clause that was characterizing these styles. So in this sense, you can see that depending on the logic we choose, we are going to get different results. So in that way, this permitted us to explore which were the difference when using one logic or another. Let us say that the best one was Kasevich logic, evaluated Kasevich logic, that is rational parallel logic. So then once we had the membership degree, one good thing that we had that was the system is so interpretable that we can also determine where a classification has been difficult. You know, because the result of the membership is not crisp, it's fuzzy. So we can see whether a classification was challenging or not. For instance, if we get 0.9 for the Baroque style and 0.8 for the Impressionism, we are going to say that that classification was a hard one, okay? And then we generate explanations. We are not going to enter into the details, but the idea is that since our system is interpretable, we can observe which color traits were more relevant in the classification, and we obtain the result. Just to put an example, for instance, if we have this painting you see that this is an almost outdoor scene. There are blues, there are grays, so our explainable system classify the painting and also explain the results. And if we observe this painting from the landscape, it is an outdoor scene. There are a lot of blues, there are some grays, so it could be said that this is a challenging work. And actually, it was a challenging one for our systems in the sense that you get a correct classification in this case, but you also get a warning, like saying, okay, I classify this painting into this style, but careful because it could be classified into another one. So in that sense, the use of logic allowed us to make this kind of nuances and to get more information. The other objective that we had was our system to be competitive with respect to other machine learning approaches in the literature. You know, since 2018, time passed and new approaches arrived, and this permitted us to compare our proposal with other in the literature, like the G48 or the Furia or what. And actually what we obtained is that even in terms of precision, our proposal was better, let's just say, okay? And also in terms of interpretability metrics. So in that way, we exemplified how even in these decades, the use of logic could serve to actually design an explainable system competitive with other ones. This was just a slide for comparing different kinds of explanations because, as Pilar will explain in a couple of minutes, we are also very interested on the explanations generated, not only in the result. Here you can see that, for instance, Schwager obtains explanations quite quantitative based, whereas our proposal is in some sense more intuitive for humans. This is another example. This is just to let there because I think that we are out of time. But we also wonder what does it mean for a classification, a classificatory explanation, sorry, to be good. And we determine a series of factors. We actually realized that our proposal was not so good in that sense, okay? But this is one idea that we like to share in the presentation, which is we have also to evaluate the explanations generated in a qualitative way. For instance, we could say that explanations need to be context adequate or personalized according to users. You know, some explanations are made for users. Other explanations actually are made to developers. Perhaps the user is an expert or not. So these are the kind of things that we are also interested in. And this was only to say that even if painting style categorization is mainly, let us say, a machine learning domain in the sense that most of the works use deep learning techniques actually. Last year and 2 years ago, I think, a survey was published and it mentioned this kind of approaches, this symbolic approach, and the same happened with a scientific report published by Nature last year, probably, which also mentioned this symbolic approach. What we want to say with that, okay, that perhaps these are also signs that that logic approach, that symbolic approach has something to say in the context of the current explainable AI. This was not a joke, but almost in the beginning we said that this case study in principle did not present so many ethical challenges, but during the years I made some reflections about the relation between art and AI, and now I believe that perhaps it's not an ethical implications-free domain, this one. So, and just to finish with this case study, if you have seen the precisions of the AI systems that we presented before, perhaps they are not so high, but it is important to say that in this context, in the context of art styles, for instance, which can be seen as classes, are not so univoc determined as one could in think, you know? So that is normal. I mean, that kind of classes in art are not so easy to define because a lot of social, cultural, or human factors are involved in that kind of definitions, of artificial definitions. And this slide was because there are even other classes in this context which are more challenges. For instance, art genres determine what is a history painting is not easy at all. And actually we also explore it, not going to enter, and the results were not so good as with art painting styles. And that's all for this subject. And
So maybe let's pause that because it was his recent PhD. We started using some results, theoretical results on universal, on fragments of denorm-based logics in fuzzy logic. And then we moved to all this work in his PhD. So I wanted to explain a bit what we have done it from the point of view that we don't vindicate that logic must be applied, but that doing interacting between certain real scenarios, we can obtain some interesting open questions to solve from the logic point, and especially also from the point of view of the knowledge representation, which is not trivial in general. The second real case is an or one in the sense that we started to work with some collectives of institutions, associations that want to improve the quality of life of people with intellectual disabilities. And then we have tried to develop different AI systems, and we have collaborated from a logical point of view. No? Okay, so the idea is that we collaborated in a project in which some people wanted to develop some tools, some instruments, what in psychology is called a scale to measure the quality of life of people with which are users of social services, not only with intellectual disabilities. So in the 80s, it arose this notion of quality of life, trying to change things in this area because they wanted to center more on the individual, not as imagine people who have some kind of impairment or intellectual disability, not treat that as a definitory trait of these people from a health point of view, medical point of view, but also to understand also the interaction with this of this individual with, in general, the society, and it changed a lot that we have passed from a model, medical model of disability to a social model. Then in the 2006, the United Nations make a convention that focused also in this notion of quality of life and try to pick up the main rights of these collectives that have disabilities. You know, okay. So in this sense, we have that a lot of social policies, institutions change also, and they wanted to find some measures, or scales in order to assess the quality of life of these people. Then it was this idea that they had to pick up not only the medical condition of these people, but how was the interaction between the skills, the performance competence of individuals with relation to all the integration facilities that give them the support. Then two psychologists, Shalok and Verdugo, started to develop a multidimensional model. They choose 8 the dimensions of the life of a person that they indicate that were important for the quality of life, and they were essentially definitory of some degrees of quality of life. Was the emotional well-being, the interpersonal relations, the material well-being, the personal development, physical well-being, the self-determination, the social inclusion, or the rights. And then they give some kind of indicators. Let's see, for example, one of them. For example, if we speak of interpersonal relations, what are social relations, contacts, emotional ties, if they are close or not to their family, if they have a special person, which is the quality of this relationship, medical interaction, not only the medical well-being, but also the relations with the people who provide this, this assessment of the medical life, which kind of family life they have, which are the relations, etc. Or if they have a satisfying sex life. All that was included in a series of questions. So they developed an scheme in 2000, and since the Generalitat of Catalonia, which is the government, create in this scale is a series of questionnaires, psychological questionnaires, and they give us the access to the answers. They pass this questionnaire to all the institutions, and they give us the answer to all the questionnaires which were related to people with intellectual disability. So the idea was that this questionnaire pick up the information of these dimensions, and the practitioners, being an educator or people who is working in social services, families, fill in a questionnaire about themselves and about a particular user in social services. This is only pictures. And then each dimension has several questions in this questionnaire. There are 65 questions into these 8 blocks, and they were related to each of these dimensions, and they reflect the indicators as we have seen before in the case of interpersonal relationships. No? So the questions allow for possible answers. Okay, as usually in this kind of questions, always, almost always, frequently, sometimes never, or almost never. And then there was a format that has not important to deal with that, in which they determinate which was the level, this dimension, and then the general quality of life. What was important of that is that they use that to develop strategies to give support to all those people. So each person had one of these profiles in its dimension and in the general quality of life. Skip on the other way now. So which were the main challenges when we will contribute? No? So I have choose 4 of them. One is then understand the relationship between various dimensions of quality of life. So we wanted to use machine learning or other systems in artificial intelligence. First of all, we tried it in 2010. Decision trees, one classical use of artificial intelligence, and recently we have other proposals that we want to explain to you. But the idea is to contribute to one of these challenges, to understand better which are the different dimensions. For a particular user, identify and key factors that contribute to the various levels of quality of life. The first one, you can see us exploring global explanations in this shared environment, and the other way, identifying that as a local explanation of a certain questionnaire of these people. And another kind of rather logical things is that the questionnaires were complex, by a diverse group of respondents for each individual, including social service professionals, educational staff, etc. So sometimes arise inconsistencies, and we want to deal with that, even not only among the people who is working with these people, but also inconsistencies between people and the result of the machine. In this case, we were doing that. It was the decision phase. Finally, it's even if the in these areas they go slow. In psychology in general, in these poor areas, when you compromise to certain people who has disability or poverty, and the investment of money is not so high, and they keep scales during a lot of time. This scale is used at this moment, but we're trying to help to update and improve this scale. For instance, there are no technology dimensions in this scale, or one thing that we are exploring is to find some machine learning methods. It's a way that we want to contribute to explain them in psychological assessment and test construction. In the sense that perhaps some we have doing a previous result on that we can identify some questions of the questionnaire that are redundant, perhaps. And so it is useful to compare the experience of people who are professionals with some results from the machine and have this kind of dialogue. So the database, it was a bit bigger than the one that we had in ours, but it has 6,103 records. We have all the picture of what people with intellectual disabilities have with respect to quality of life using this scale. And then we did recently some contribution in the line of doing hybrid systems, not poorly explained about classical systems, but another different ones. If you want to explain the details.
Yes, so the idea was to study this database using current explainable methodologies. So we determined, since we were running away from the quantitative approach, we determined 5 classes for classifying the quality of life level from very low to very high. And we use actually logic explained networks, which are just a family of interpretable deep learning models introduced by other authors, as you can see on the slide. And the idea is that that family of deep learning models need understandable concepts, which are the input concepts name, and then it gives explanations of the classification or the prediction of the model. What is the idea? Let me explain it a bit better. Sorry. We have 2 kinds of explanations, local and global. As already Pilar said, local explanations are those explanations which are explaining a particular prediction of the model. In the sense, in our context, there is a social service user and one practitioner make a prediction of the quality of life of that user, or an AI system make a prediction of the quality of life of that specific user. That is a local explanation, and from a logical point of view, it's just a conjunction of literals. Those literals are indicating which dimensions were relevant or not when determining the quality of life of that user. And then we have global explanations. Global explanations, in some sense, explain the logic behind the model. Remember that we had 5 classes for the quality of life level, so we are going to have 5 global explanations. Each one is going to explain each one of the levels for the quality of life. From a logical point of view, global explanations are just aggregations of local explanations. These aggregations can be trivial in the sense that, guess that you have, I don't know, 1,000 you have a database with 1,000 of responses to the GenCat scale. And you train the database with that data. Then what you can do for obtaining global explanations is just aggregate all the answers together using these junctions. There are other approaches like saying, okay, let's be more selective, perhaps we could just select those more repeated local explanations or things like that. But from a logical point of view, global explanations in this context of logical trained networks are just aggregations of local explanations. And what was the idea? We actually designed the system.
Sorry,
when
can I ask something about this? So the local explanation.
I'm almost there. This is why.
Sorry. So the local explanation. You said that there are various parameters for life quality, right?
Yes,
and you
like
also said
8 dimensions.
Yeah, exactly. How many? Like eight.
Eight.
And you also said that there are like 5 levels: low or very low, low, medium, high, very high, something like that. And here in the local explanation, you don't have a number attached to it, right? It's not like before where you had like, you know, a literal and a number. Here you don't have the number.
I don't.
Here in the horn clause that you had before, you had like a literal and a number in the antecedent of.
Yes, no.
Here
sorry. It's
don't.
classical logic, sorry.
No, just to understand. So
Classical
here
syntax.
and no, because I was just thinking that maybe you were reproducing what was going on before with this 5 levels. So it's just that you have like 5 numbers,
Yeah,
1 to 5 or something like that, but not here.
Not here because actually this was not our framework.
Okay. Right.
Networks, now I understood that.
Okay.
That would make sense actually using that. We have thought about that.
Okay. All right. Thanks.
And so the idea is that we get 69 questions, answers to the GenCat scale, and the input concepts are actually the value of each one of the 8 dimensions. For instance, if in the first dimension you have a value of 3, perhaps it is labeled as height or whatever. And then, since you mentioned a former question, actually, since we are working in classical logic, we needed to expand for sure the variables that was related. We didn't have, sorry, because I didn't answer probably.
No.
We didn't have 8 propositional variables as input, but 4. Because for each level, we needed to convert this was pursued. And then we obtain the values, and the output again, as in the appendix, is just a classification and the explanation of the classification. So, for instance, an example could be that one. This is a global explanation, okay? Because you see ors and see that it is not just a condition of literals, and the idea is that the quality of life level is very low when one of these situations happen. Only one dimension is in one way or in another. We have, if you see this and you pay attention, you will see that this is actually a conjunction. This happened because we didn't have enough data into our database to choose. To choose different meaningful local explanations. So these things happen. And then, as Pilar said, our idea here was not only to predict the quality of life level of practitioners, but also to help to understand the knowledge that we could extract from real data from the practitioner. So we obtained these 5 global explanations, one for each level, and another challenge that Pilar mentioned was to understand the relationship between the dimensions. So we made a little modification in the model. Now the idea was to predict the value of a dimension from the value of the remaining dimensions. You know, the inputs now are 35 variables, and then we have and you can predict the value of the remaining dimension. And we here obtain mainly almost local explanations. So this indicated in some sense that actually the dimensions were quite correlated between them. Now this
Yes, it's only to
Right.
finish, to see
Yes.
another application of logic. I know that we are moving very fast, one thing is, it was only the idea to see, focus on the case study and see different contributions. For instance, what has explained Vicent has a lot of machine learning also that we have not introduced. But there is the, is to say, how logic can try to contribute to all these ideas. And in this last example is the case that we have a diverse group of people answering the scale for a particular individual and they don't agree. So we try to have a belief merging, a classical approach in logic, which is belief merging. And you, so the idea is that in belief merging, it's a methodology common with other operators in logic related to update or revise our information or our beliefs. And then the idea is that we can combine multiple knowledge bases into a single consistent one, because we usually in the interesting case we have knowledge bases that are mutually consistent. And then the idea is translate that into our problem, our challenge, to have different assessments of the same individual. So we use it in this case another logic, which was signal logic. It's a very easy extension of classical logic, in which you have different values, but the connectives are interpreted in a classical way. So the only difference is that you have signet literals, in which the sigma is a finite, usually finite set of values. You can say, for instance, you have 0, 1, and something in the middle. It was very popular in satisfiable in problems related to the satisfaction of clauses in finite many logic some times ago, because in polynomial time you can translate any finite multi-value logic to this signal logic, and then if you achieve some model that satisfies the clauses, then it happens also in the translation to the finite many-value logic. Then we consider that given the answers to the questionnaire was one of the simple formalisms we wanted to use. And what we wanted is to implement that. So what we do is to use a simple fragment, the whole fragment of this kind of expressions. This expression means that the value P1 is bigger than or equal to 0.1, or that P2 can have any value. Then we choose as variables the different dimensions of quality of life and express the different profiles. Imagine you have 4 professionals, and then we will express in this case, we have restricted this, it's a toy model. The fractionals establish a relation between the physical well-being and the level of quality of life. And they express, given a particular individual, which was this using signal logic. In fact, they express in a natural language, but was very easy to translate into this kind of logic. And then we applied the usual tools of belief merging, but we developed all the theory related to signal logic because it was not introduced before. So from a theoretical point of view, without entering into detail, belief merging is an aggregate. If you consider model-based, it's an aggregation problem on rankings of possible worlds of logical formulas. What does it mean? That if you have inconsistencies in different mutually inconsistent knowledge bases, first you identify the set of models that identify each individual belief base, and then you compare the models, and you fit some kind of distance or pseudo distance, and you compute the distance of each model to all the other belief bases, and then you aggregate these distances. What is the intuitive idea? That you want to find these models that are closer to as much close as the other belief bases, to finally select the models that minimize this aggregated distance and construct a new belief whose models are exactly the selected ones. So this is usually the case in merging in general, in classical merging, and we develop all that for signal logic, and then we apply it to this problem. So we obtained a sentence that the models of this sentence in signal logic was as close as possible to the original belief bases. I'm not going to enter into that. It's all part of the implementation of the process. And the idea was you have the models, you have the distance between each model to each node edge, and finally you aggregate that and choose the corresponding models which are more close to all the knowledge base, depending on the criteria you have used in this case, but I'm not going to enter into details. But the idea is very simple, to choose distances between the respective models to each of the knowledge base, trying to find something which is close. No? And then what we did is first to develop all the theoretical part, characterizing this kind of models that were both models of signet regular Hom formulas. And then, as usual, we try to present characterization theorems saying that our operators were adequate from a logical point of view. It's a usual characterization result in this kind of logic belief changing methods. And finally, we did quite an implementation of the process, because since there were a lot of variables, since we translated into classical logic, then it was very difficult. In fact, the point here was also to try to implement something, because usually there is a lot of literature in belief chains, but not implementing. So what our question was, I think there are big and very interesting contributions from a logical point of view, and all is very adequate, but which is the rationality under each different contribution in this field, because we cannot see in real applications these processes, and we are not, it's not clear if they are useful or not, even. No? So I think we wanted, there was another paper that contributed to cancer, I think so, and another group that make a contribution implementing the classical belief merging method, but there was no continuity. So our idea was also not only to try to solve this idea and have a dialogue with the professionals in order, if they look for this process and see if they are useful or not, but also to contribute to this community and putting some questions of how we have not implemented different perspective, and we know that their value only from a theoretical point of view. So this was all. So we had this idea that we try to experiment a bit in artificial intelligence and logic, and it was this idea for this course. What role should logic play in the new area? Our idea is that we want to avoid to deal with more with databases that are bigger than the ones we have done, even if logic has a clear role in having smaller databases, and to deal with this qualitative point of view that contributes to hybrid systems, but taking the artificial intelligence as what it is, and the recent developments of machine learning, deep learning, and in other areas. So, okay, thank you very much for